Hello everyone, here is a video on mole calculations, but next level. We're going to go level 2 here, okay? So as you know, 1 mole of any substance has a number of particles, and that's 6.02 times 10 to the 23rd, okay? Because that could be atoms, molecules, or it could be ions. But 1 mole of those 6.02 times 10 to the 23rd particles also has a mass. It's called molar mass. If you remember, anytime we find the molar mass, or need a molar mass, or mass is mentioned or given, we have to look on a periodic table. So that's our main focus for this first portion. When I look at these things, these compounds, I must look at their molar masses on the periodic table. So if it was just carbon, it has a molar mass of 12.0 grams per mole. If it's hydrogen, it has a molar mass of 1.00 grams per mole, okay? Notice I'm always using 3 numbers. And yes, you have to have the 0.0 and 0.00, okay? So with this, I have C2H2. Notice I have this now. So what I need to do is not just count 1 carbon or 1 hydrogen, but 2 carbons and 2 hydrogens. So when I take 63.2 grams of C2H2, and it asks me to solve for moles, grams are given, so I got to put it on the bottom. No problem here. I'm going to convert to moles, and for now it's always 1 mole. Okay, grams cancel, but I'm missing a number. And the way I figure this out is I look up the molar mass of carbon. Now, again, I'm going to use 3 numbers, but for all practical purposes, it's just 12. So the molar mass of 1 carbon is 12, but I have 2 carbons listed. So that's 12 plus 12, or 12 times 2. So that's 24 grams per mole for just carbon. And again, now I look at hydrogen. Hydrogen has a molar mass of 1.00, but there's 2 of them. So 1 times 2 is 2. What do you think I do to these 2 numbers? If you said add them up or thinking add them up, 26 grams per mole, that's correct, and that number goes here. Little extra step here. Whenever you see a molecule, let me summarize. Whenever you see a molecule, such as this, and not a single element, you must add up the molar masses. Add the molar masses. And where do you find molar masses? On a periodic table. That's where I'm getting all these numbers. Okay, so if you're confused on where I got those, bring up a periodic table and you'll see that the molar mass of carbon is 12.011, and hydrogen, I believe, is 1.01 something. But again, that's we're just rounding off that 1. So let's solve. You're going to take 63.2 divided by 26, because the 26 is on the bottom and the 1's on the top. 63.2 divided by 26 is 2.43 moles of C2H2. Okay? Notice I keep mentioning this here. Okay? All right, let's jump down to the bottom here. Now I have grams to moles. I'm sorry, let's do this one. Convert 412 moles of HNO3 now to mass. This is opposite of what we just did, but same process though. Just opposite as far as what we're converting from and to. So 412 moles of HNO3. And I got to get that to mass. Okay, so let's go as far as we can in the problem. I have moles of HNO3 here. Let's put moles of HNO3 here. And again, whenever you see moles, you should put a 1. But now I'm going to grams. It says mass. So grams of HNO3. Okay. I have an H, an N, and 3 O's. So when I look up these things, let me just use this down here. Use this space to convert. Oops, that was crazy. So if I have HNO3 and I need to add up the molar masses, this has a molar mass of 1 gram per mole. This has a molar mass of 14 grams per mole. And this has a molar mass of 16, but there's 3 of them. So 16 plus 16 plus 16, or 16 times 3, is 48 grams per mole for all the oxygens. And notice I'm adding them together. So that's 48 plus 15, 48, that's 58. That's 63 grams per mole, I believe. Let me just add that up. 48 plus 15 is 63 grams per mole for HNO3. Where does this number go? It's not an answer. It goes right here. 63.0 grams per mole. Cancel, cancel. In this case, I'm going to take 412 times 63 because it's on top. Oh, and you end up with a huge number, 25,956. And we'll put all numbers down for now. 25, what was it? 25,956. 25,956, and here you go. Grams of HNO3. Notice it's grams of HNO3 because that's what was left here. Okay? Now, let's move on. Okay, now, the hardest ones you can do are number of atoms. Mass to atoms or atoms to mass. Okay? Actually, these are the hardest. So let's do this one here, first this one, and we'll do this one second. Okay? And I'll do more in class, obviously, because this is a difficult concept. All right, so what I have here is 5.12 grams of potassium, and I want to know how many atoms that is in that mass. Well, so far, we've always included moles in our calculations. Not now. So what I'm going to do is I'm just going to set the problem up as far as I can go. Grams of K. Well, it says number of atoms, so atoms of K. Okay, now, whenever you see grams, what do you have to use to have grams? If you're thinking mass is listed, so I need a periodic table, you're correct. And when you look up the molar mass of potassium, it's 39.1. Put that here. Okay? The next portion, and once you get used to it, is actually quite easy. Whenever you see atoms, molecules, or ions, what number goes with that? 6.02 times 10 to the 23rd. So I set the problem up, and I didn't have to do actually too much thinking here. But what you're going to do first is take 512 and multiply first these two numbers. Okay, we're going to multiply first. So take 5.12, I said 512, it's 5.12 times 6.02 times 10 to the 23rd, press equals. Your calculator says 3.082 times 10 to the 24th. Leave it in there. Don't touch it. Don't press clear. Don't write it down. Just divide by 39.1. You end up with 7.88. So again, you're going to divide now by 7 and you're going to get 7.88 times 10 to the 22. 7.88 times 10 to the 22. And what are your units? Atoms of K. Right there. Okay? See if you can get that in your calculators. Again, I will show you how to work with that a little bit later. Okay? Let's take a look at this one, number 2, that I circled. It's in the middle of the screen or somewhere close to that. 0.75 or 0.75 grams of water to molecules of water. This is the hardest of the hard. If you want to try to pause the video at any point in time and try to get this done on your own, go for it. So, 0.75 grams of water. I got to get to number of atoms. So let's go as far as we can go without worrying too much about numbers just yet. Okay, I always taught you if you have grams of water here, mathematically it has to go on the bottom to cancel. Okay, so grams of water. I'm trying to go to number of molecules. So let's, and yeah, you got to write this out. You got to write molecules. I write it sloppy, but anyway, you got to write it. So molecules of H2O. Okay, now what numbers do I fill in here? Well, it says grams of water, and anytime grams is mentioned, you have to use a periodic table. So when I take water, I have to find the molar mass of hydrogen. That's a molar mass of 1, but there's 2 of them, so there's 2 grams per mole of hydrogen. Now I need to look up oxygen. Oxygen has a molar mass of 15.9. We'll round that up to 16.0, but there's only 1 of them, so that's 16 grams per mole. And again, I'm adding them. So water has a molar mass of 18 grams per mole. You'll get used to that because we use water quite a bit. Where does 18 grams go? It goes right here. The number of molecules, again, what number goes with atoms, molecules, or ions? We used it above in the first problem, and that number is 6.02 times 10 to the 23rd molecules of water. So what do you do first? Mathematically, you're going to multiply these two numbers first. So 0.75 times 6.02 times 10 to the 23rd. Oh, I just screwed up. 0.75 times 6.02 times 10 to the 23rd gives me an answer of 4.52. Actually, my calculator says 4.515 times 10 to the 23. Now, you take that answer and divide by 18. Divide by 18, and your answer is 2.5 times 10 to the 22. So I'll write that answer here. 2.5, actually I said 3 numbers, 2.51 times 10 to the 22 molecules, and yes, you have to write it out, of water. And that's that answer there, okay? ladies and gentlemen, that's about as difficult as it gets. Okay. More on this as we go through. But if you have email questions, please email.